Thank you.
Okay, hi everyone. Welcome back to CSCI 100 to another one of our career talks. We've recently heard from a UX designer. We've heard from engineers, a software engineer. We have a product management talk coming up. But today we're going to talk on one of the other tech roles, other paths available within kind of tech is, and it's a site reliability engineer. Very technical work and very kind of similar in the same vein as software engineering, at least the same technical skills, but focusing on a different part of the engineering stack. And today we have Gabby Jackson here, who's a site reliability engineer at Google, and she's going to tell you about her work. So take it away, Gabby.
Hello. So today we're going to be talking about how do you measure reliability, and a little bit about me before we get started. I graduated from college in 2020 with a bachelor's degree in computer science. And while I was in college, I actually had two-step internships for software engineer jobs at Google. And currently I work as an SRE under cloud in Kirkland outside the Seattle area. And a little fun fact about me is that when I was an intern on my first team, I went ziplining, which was a really fun experience, but very scary. So today I'm going to do a little explanation of what site reliability engineering is, and then we're going to go into a concept that SREs deal with a lot, which is how to measure reliability. So getting started into what is site reliability engineering and why do we have it? Site reliability engineers, or SREs, are software engineers on a unique mission to make Google keep working. And that's kind of a really big statement, but we use a mix of proactive and reactive engineering practices to make our planet scale systems better. And the reason why we do that is because our users expect Google to be always available, fast, operating correctly. A lot of times when people's Wi-Fi is down or they're trying to figure out if their Wi-Fi is working, the first thing they do is go to google.com and see if search loads. So it's really important that our services are running, in the best shape possible all the time for people all around the world. And if anybody has questions, please jump in and ask them throughout the presentation. So I'm going to jump into what proactive engineering is. That looks like a couple of different things. One of them is automation. We have SREs who do great work, but we want to make sure that they're not doing repetitive tasks that we can automate. So on a very small scale, that might look like writing some scripts to make one or two aspects of your job easier day to day. All the way to large scale, we have robots to do all the functions that we don't want humans to spend hours and hours doing. SREs also do a lot of consulting work and launches. So we work with product managers and software developers when products are being built and features are being launched to make sure that they scale properly and that they're reliable and that they're safe for our users. And SREs can get involved in any part of the process from development all the way to reviewing right before something launches. And SREs also have a concept of disaster games, which sounds kind of weird from jump, but we do a lot of practice into making sure that SREs know how to respond to emergencies. So sometimes your team will set up, a scenario saying, hey, XYZ breaks, how would you handle it? And we walk through the steps of how to handle it so that our SREs know what to do in case there is an outage or an emergency that we need to handle. And that way we can also test that our tools work. So when something actually comes up, we know that we can rely on our services. Does anybody have any questions about the proactive engineering side of things?
Looks like
If not, I'll jump.
Hrishav has his hand up. Yeah, Hrishav, go ahead.
Yeah, correct me if I'm wrong, but this is the same thing which happened with Facebook a few months ago, right?
I'm not actually sure what happened with Facebook. I know what happened, things were down, but I'm actually not sure about a lot of Facebook's practices in terms of that.
I can chime in on this. This is my area of kind of research. They had a networking meltdown. Yeah, it was exactly like people like Gabby, like SREs that would be paged to figure out what in the world is going on. In Facebook's case, they're like the service that basically tells you how to reach facebook.com that exports kind of Facebook's range of addresses like broke. And basically it made it impossible for anyone on the internet to actually access any of the Facebook resources. Like the servers themselves are still running, but you didn't know where they were. And it took SREs like a lot of work to figure out how to fix that. But yes, it was exactly SREs that would be paged for something like that.
Thank you.
Thank you. Okay, I'll move on to talking about reactive engineering. So a lot of that, as was mentioned, is in case there is an active incident, SREs will jump in and try to fix things and get things back to normal as soon as possible. But we also do things before those things happen. So we do a lot of work on monitoring because our services are huge, they're planet scale, and we can't have a human looking at every single function of every single service and every single metric all the time. So we have a lot of monitoring tools to aggregate the data that we have and visualize it, and also to set off alerts so that SREs know, something's wrong, we need to start figuring it out. And SREs also do a lot of debugging and troubleshooting work. So taking, an end user's experience of something's broken, something's not working, and tracing that back and seeing how different services interact and trying to understand what went wrong and fix it so users can have a great experience again. And there are a couple concepts that we talk about in site reliability engineering pretty often. So one of those is hope is not a strategy. And what that means is if an SRE is asked, before something launches, how is this going to scale? How is this going to be reliable? Have we tested this? We can't just rely on hoping that our users are going to, not test our service to the limits, or we can't hope that something will scale. We need to make sure that we're actually engineering to think of these worst case scenarios, to think of how a service is going to scale to planet size, to millions of users. And we also try to balance reliability with velocity, because it kind of sounds like SREs just sit around and say, no, we're not going to launch that. No, that feature's not going to work, but that's not really true. SRE's goal is to get things launched as well. We're not just trying to prevent any new features from rolling out. So we have to balance making services that are reliable and that will run and that are safe with actually launching those features and releasing them quickly. So does anybody have any questions about the SRE overview? If not, I'll move on to a concept that we use in SRE a lot, which is how we measure reliability. So what does it mean to be reliable? And if we look at it abstractly, if a service is reliable, it's never going to fail a query, ever. Everything's always going to work right. You're always going to get exactly what you want quickly, safely, all the time. But Google and all of Google's services have hundreds of thousands of queries every second. So perfect reliability is just not possible. Something will always go wrong. Well, something can go wrong at any point. So instead of shooting for perfect, let's try shooting for something else. So we have a concept of measuring reliability, and I'm going to walk through an example in the next couple slides. Let's say you have a service like a campus website for figuring out what lunches are being served in different cafeterias. I know my school had that, and I used it all the time when I was in college. So let's say this campus web service gets 10,000 queries an hour. And in that hour, it drops 10 of those queries. So we take the 9,990 queries that were good and divide that by the total number of queries, and it becomes 99.9% reliable. So in SRE, we call that a 3-9 service because there's 3 nines, 99.9. So we can extend that from queries an hour to actually looking at time. So treating an hour where a query fails as a bad hour, treating a minute where a query fails as a bad minute, treating a second where a query fails as a bad second. So if we take the amount of hours in a day and the amount of days in a year, and we want 99.9% reliability for a 3-9 service, that means we can have 8.7 hours of downtime a year. If we take, instead of having a 3-9 service, we have a 5-9 service, then we take number of minutes in an hour, hours in a day, days in a year. We're allowed 5 minutes of downtime each year. So we've seen how we can measure reliability, but how much reliability do we actually need? Because it's not realistic for us to have a service running 100% of the time, all of the time, because like I mentioned earlier, there's always a chance for something to go wrong or break. We can't factor out all of that in our services. So it kind of depends on the service. The example I mentioned earlier, if you have a campus website that shows lunches, people probably don't need to see what lunches are going to be on Friday at 2 a.m. So you could take down that site for 40 minutes each day, or 40 minutes each month, I'm sorry, and you would probably be fine. But we can't necessarily do that for something like Google search. So the amount of reliability we need, the amount of nines that we rely on is really dependent on the services that we're talking about. So now we know how to measure reliability, we can set a reliability for our service, and we actually have to meet it. And in theory, we just shouldn't be able to break anything, right? But there are actually a lot of things that could come up to threaten the reliability of our service. So at Google scale, something can always break. We have a lot of servers, so that means at any point, some hardware could be down, some servers could be down. We can do maintenance on data centers. So an entire data center could be down for hours, days, weeks. We have unplanned natural disasters because our data centers are on Earth. So hurricanes, earthquakes, any type of natural disaster could strike our data centers and the people who work in them. So that could take out a data center. We have unexpected bugs in services where we try to test to get all the bugs out as much as possible, but things come up and a launch could introduce a new bug. We have power failures, network failures, data corruption from hardware, and sometimes if an SRE is trying to fix a problem, we accidentally make things worse while trying to debug or trying to repair a service. So given all of these things that could break, how can we run a reliable service? We use redundancy. So if we need N servers and data centers and replicas, we like to have N+1 because one of those services, racks, data replicas, machines can break or can be out of service or can be maintained or can be taken out for maintenance, and we could still run our service properly and our users could still have the experience that they expect.
I see there's a hand up. Rishabh, did you have a question you wanted to chime in with?
Oh yeah, sure. Or I could ask at the end also if that's fine.
Is that better, Gabby? Or yeah.
No, you can feel free to ask.
Oh yeah. So my question actually was, you mean drop meaning the example which you gave for the 10K cases? So the drop meaning that the 10 cases are like broken. A 10K
that could be any number of things. That could be, they're dropped, the query isn't received properly, the response isn't sent back to the user, it could be really slow. That could be any number of things that could break. So just not the ideal, you type in something, you get a result back in whatever, how many seconds, milliseconds you expect.
And so so this is random, right? Like any of the 10K queries can break, any of the 10 among the 10K?
Yeah.
And one more question.
One more
question was,
I was going to add, Rishabh, as a concrete example, since for my product that I worked on was YouTube. For us, it would be like we would kind of count like it as dropped if it takes us more than 2 seconds to if you try to request if you try to sign up for YouTube Premium and it takes more than 2 seconds for us to give you back the page, then we assume that something has failed, and that counts as one of our dropped queries.
Oh, so that's cool. So the next question I was about to ask was, so you said every year there's like 5 minutes of downtime in Google servers, right? So are those downtimes strategically planned so that users don't notice them happening, or are they random too?
So for let's say like a 5.9 service, like you mentioned, they're not really planned. It's just more that we're trying to make our services reliable, so we don't have that. So we're not, going in and saying on March 2nd, we're going to have 2.5 minutes of downtime. It's more that we are, this is hard to explain. we want to make sure that we have a little bit of budget so that we know how rigorous our services need to be. So we can maybe do a little bit more maintenance on a service that requires 3 nines worth of work. We have a little bit more area to launch something versus 5 nines, 6 nines, 7 nines, something like that. Does that make sense?
Kind of does. Thank you.
And I see Tyler
Are
also
there
has his hand up. Tyler, go ahead.
Mhm.
Now you mentioned redundancy, getting back to where we just were. Are we talking networking redundancy, as in there are a increased number of servers, or redundancy within the software so that if one part of it fails due to an update or something, another part picks it back up?
That's a good question. I'd say it covers pretty much everything. That sounds very vague, but in terms of servers, like physical things, even data centers, if we're relying on one data center to do something, we want to make sure that there's a backup that we could switch to if something happens, but also things like, data replicas, more software paths so that we know that we can, if something goes wrong, we do have that backup.
And does this include things like, oh, you just mentioned backups, never mind. Thank you.
Of course.
And as you take more CS classes, you'll learn like it's not even like some kinds of redundancy are just built into like how memory works. Like even within a single hard drive on your computer, there's called it's like RAID 5 or RAID 3 or RAID, like there's redundancy that happens where they store like duplicate copies of your data, or even like smart ways to mathematically recover your data if one part of your drive gets corrupted. So you'll learn about these redundancy concepts later on, even in your curriculum at Howard when you take like a computer architecture course. But there's another question in the chat for you, Gabby, which was, does Google offer any program where one could work with a certain type of occupation, like SREs, data scientists, et cetera, and specifically for internships? Are there internships for SREs?
I think there are internships for SREs. I'm not sure about data scientists or the other occupations, but I was actually never an SRE intern. I was a SWE intern, but I had friends who were SRE interns, and I am not 100% sure about this. So definitely check with the Google recruiting website. But I believe that if you apply to programs like the SWE internships or STEP internships, you could be placed on an SRE team and do projects with them and see what their day-to-day is like. But I believe that would be part of the regular internship, software engineering internship pool.
Thanks.
Yeah, but again, please feel free to email. I don't have the contact information, but like the Google Students, Google Recruiting website. Okay, great. So on to redundancy. We like to have N+1 of everything, from rack switches to data replicas to entire data centers. So in having N+1 units of whatever we need, in having this redundancy, we can also do maintenance without the user noticing. So like in the example I mentioned earlier, we don't have to take down a full site for 40 minutes each month to do maintenance things. We can do updates without failing our users or without having users have negative experiences or bad experiences. So it's really nice if we can get to N+2 copies of things or N+2 replicas, N+2 redundancy, because we can do maintenance on one copy, we can have something go down in another copy, and then we can still have a seamless, uninterrupted user experience. So we have N+1 replicas of data centers, data replicas, machines, servers, whatever we need. But it doesn't matter what we have these replicas of if we can't actually use them. So as a part of the proactive engineering that I mentioned earlier, SREs make sure that we have software to handle failovers to our redundant pieces. And we practice those and make sure that they run. And we work on the infrastructure to ensure that our redundancies can be incorporated into a service if we need them. So we've measured our reliability, we've decided how many nines we need for a service, we've built our redundancies, and at the end of the day, SREs continue working, Google services are working as expected, and we live to serve another day. So if you're interested in learning more about SRE and the concepts that I talked about today, I highly recommend these books. I've actually personally read the book on the left, Site Reliability Engineering, and they're free at sre.google. You can go and also see interviews with other SREs and people who've been working. Google actually founded the SRE discipline in 2003. So you can see interviews and videos from people who worked on SRE from the beginning and have seen it evolve into what it is today. So that's all I have for the presentation, but I'm happy to answer any more questions if anybody has them.
I see, Rishabh, you have your hand up. Go ahead.
Yeah, the lizard on the book seemed quite fascinating to me. What's the secret behind choosing a lizard on the theme of the books?
I'm actually not sure. Lizards don't come up in my daily work that much, so I never noticed that. There are 3 different lizards. That might be on the website if you look.
Yeah, and another question was, okay, since although you're new to the SRE role at Google, since you graduated last year, was there any real life situation or say trial where you had to go through this kind of situation, and how did you handle it?
So yeah, I've been on call for work, and I've had to handle, emergencies and situations. And one thing that's really emphasized is relying on your team members and relying for help. So definitely one thing I do if I look at a problem and I don't know how to solve it is I will start asking for help for my team. I will ask other teams for help if it's related to something that they do. So that's something that's really encouraged in SRE is, depending on your teammates and working together. We don't want to have, one person just running around trying to save an entire service. So yeah, we do a lot of work with teams and, being able to help out if a coworker has a question or if something happens, all hands on deck kind of stuff.
Or like, can you be more specific about like a specific time when Google servers crashed and you guys had to come on the scene, like an emergency kind of stuff? Has that happened?
Not that I've really been involved in. Yeah, we just have. Yeah, I haven't been in any like huge incidents, everything's crashing kind of thing. But a lot of ours are actually a lot of incidents that we deal with. We actually kind of take the same procedure. So, working with the team, using our monitoring systems, getting an alert from somewhere. And so it actually is the problems that we deal with might be different, but the actual practices that we implement are pretty much the same.
Thank you. I think I figured it out. I think I figured something out. He said monitoring, and that's a monitor lizard. So maybe that makes sense now. Why the lizard is in there?
Wow, I did not know that. Maybe that's it.
I'm taking a guess. I'm taking a guess.
I have a question for you, actually, Gabby.
Mhm.
Could you talk a little bit about, like what happens when something goes down? Like, oh, someone writes a line of code that causes things to crash. Like, what does Google fire them, or like how can you talk a little bit about blameless culture and about what a postmortem is?
Yeah. So, like you said, SRE and Google as a whole has a blameless culture. And so when, we have an outage or something breaks, we don't go around and say, who wrote this? Who did this? Did you do this? We just work on fixing the problem and getting our services back to normal. And then after we have, everything's back to normal, we start working on a document called a postmortem, which is it summarizes what happened, the things that happen, because there's usually 2 or 3 different causes. Things have to kind of line up for an outage to happen or a service to fail. And in those documents, we make sure never to place blame, like so and so wrote this line of code and that's why things broke. We really try to be anonymous and focus on how we can fix the issue in the future and prevent it from happening again, rather than figuring out so and so did this, so and so broke this. So we really make that as blameless as possible.
And
Did that answer your question?
that did. I'll add a sentence because this is something I've loved about Google is their approach to when things go wrong. It's not ever like if I push a line of code that breaks something, it's almost never my fault. It's this like there shouldn't be a system in which one person can push a line of code that like takes everything down. And so I think Google kind of use it as a system. And you see this reflected everywhere. Like any code that goes out into production at Google has to be looked at by at least one other person and like explicitly clicked like this code is okay to go out. And like that's one line of defense. That's one place for redundancy where even if I look at something and I make a mistake, I need someone else to also look at it and also think that it's correct. And then there should be systems along the way that first test that code before it gets pushed. And so if I'm able to make a change that takes down Google, there's something wrong with the system that we're using, not necessarily something wrong with me. And that's kind of that underlying blameless culture that Gabby was mentioning that just I've personally really enjoyed. Like, it's nice. I don't even ever feel stressed about the changes I'm making.
Mhm.
I see Jamar has a question for you. Outside of a degree, is there any necessary experience for someone trying to enter the field?
That's a good question. I didn't really have any experience. Like I mentioned, I had done SWE internship, software engineering focused internship. So I came in kind of, not knowing anything about SRE, but I would definitely say just being able to problem solve is a really good thing. Getting practice into kind of debugging things and really having an interest in looking at a system from, beginning to end, because SREs do have to, understand how things interact and be able to figure that out when an incident comes up, because we have so many things that overlap and work together. So really being able to understand the system from beginning to end and being able to walk through that process. But I wouldn't say there's like any classes, at least that I took, that I think made me a better SRE versus like a different computer science related field.
I see Tyler has his hand up. Go ahead, Tyler.
Now, I know you just said that there were no classes you took that made you a better SRE in the long run, but are there any on-site best practices you've picked up that would say have helped you over your career?
I think a big one is asking questions, which sounds very vague and generic. But what I've noticed about SREs is that really asking questions and really understanding how a system works and not just assuming that, oh, this piece is going to work. It kind of goes back into something I mentioned. Hope is not a strategy. We don't just hope that our services work. We need to be able to unpack and really look and say, like, how does this work? Will this work? What happens if XYZ breaks? Why did that happen? So I think that that's a skill that I really had to develop, especially coming out of college, with a CS degree. You're given a project, your professor says, I've built part A and part C, you just need to build part B in the middle. Versus SRE, you're expected to understand how A interacts with B and B interacts with C, and do A and C have a dependency that we don't know about? And what happens if something in B goes wrong? Does that affect other services down the line? So really being able to dive into a system and examine each and every part carefully and ask those questions.
Thank you. That makes a lot of sense. I also wanted to ask, and I'm hoping I didn't just forget the question. I forgot the question. Sorry.
Jamar has another question for you in chat. And then in the meantime, Tyler, maybe this will jog your memory. What was the most useful resource you utilized to help build your skills for performing well on the job? For example, I know you stated that you would ask questions, but did you utilize a certain program or exercise or anything along those lines to help you build your skills?
That's a good question. I would say that one thing for me that really helped was just trying to understand my system as a whole. So, for my team, I spent time just drawing out like in Google Docs or something, just saying like part A goes to part B goes to part C, this depends on this. And that, I guess the tool is like Google Docs, trying to just understand how things work and really be forced to explain it. Like I know there's a phrase that you really understand something when you are able to teach it. So being able to teach it to myself. But in terms of tools, I would say that, yeah, that was really the biggest tool because you can have all the alerts and monitoring and setups and code editors or what have you in the world, but if you don't understand what is going on in the system as a whole and why things are doing what they do, it's very, very hard to debug a problem. I hope, did that answer your question?
Sounded like a
Okay,
yes.
great.
Also, I have another question. So, what I want to ask is that do you spend more time creating like your own code, or do you? So I know that like overall, a lot of occupations at Google work together in order to accomplish like a certain goal. I know that the goal of like an SRE is to help make sure that Google can run. So I was wondering if you all take like code that some other occupations, like for example, like this software engineers. So do you just look at their code and then you just make like modifications, make sure that you just create your own stuff entirely to make it easy to redundant and does that make sense?
Yeah, I'll repeat it just so that I get it. So are you asking like, do I spend more time looking at other people's code and designs or coming up with my own kind of code or designs?
Oh, really from Atlanta, just Perry.
Okay. I would say this is going to sound very vague, but it depends on the project. I've been involved in projects that are more focused on, like I mentioned, consulting and launches and reviewing other people's, designs and launches to make sure that they scale. And if I'm working on a project like that, then yeah, most of my time is going to be spent reading other people's designs, reading other people's code, asking questions, and maybe adding a piece here and there for reliability, but really not building stuff. Sometimes, on the other hand, if I'm working on, adding to our monitoring, for example, then I spend a lot of time reading my own code, getting my own code reviewed, writing my own designs. I kind of want to say that an SRE reads more of other people's code, but I actually don't know if that's true because I feel like SWEs at Google also do a lot of collaborating. So there is an element of collaborating. So I would say it depends on the type of work you're doing that day, that week, that quarter.
Okay, that makes sense. Oh, and I have another one. It just came to my head. So, as a position-wise, normally, if you think of anything that's like in corporate business or so along those lines, you see that there's like a certain growth. So like you may start off as like maybe an associate, and then you may become like a manager, and so on and so forth. I was wondering if, as a site reliability engineer, is there like a certain like ceiling and floor for your occupation? So like you get promoted to like maybe like site reliability engineer manager, or is it just that everyone's just kind of in the same position?
Yeah, that's a good question. So I would say that the position really depends on what you want for it. There are senior SREs who kind of look at more of who might work on a team but aren't managers. So they'll do a lot of designing and helping other, people on their team. There are, managers who manage people, and it actually is pretty similar, I'd say, to the SWE ladder at Google. So you do have, you come in, new grad, and you can work your way up and you can decide, do you want to be a manager? Do you not want to be a manager? I am very early in my career, so not making those types of decisions yet. But yeah, there definitely is career progression, and it's not just like, oh, you have to manage people or that's it. That's like as far as you can go.
Okay, yeah, I've got another one. So how fluid would you say the occupation is? So let's say
Oh, I think you're cutting out.
Yeah, Jamar, could you type out your question actually?
yes. Oh, sorry.
Yeah. Okay. In the meantime, while Jamar's typing that out, it looks like Tyler might have remembered his question.
I hope I remember the question, that this is the right one, but as a software reliability engineer, you said you had to read through other people's code to recognize how it works and functions all together. Has that result, like, how much of an understanding of code overall and like multiple languages would you say that takes?
I'd say that it takes some amount of skill, but I've also noticed that sometimes if I am reading in a language that I'm not super familiar with, then I'll just set up a meeting with the person and be like, hey, can you walk me through the design of this code? So instead of reading, line 202 said that you put a semicolon, it's just trying to understand overall what happens in the code and why something was designed the way it was. So I would say that if you aren't confident in like, I don't know, JavaScript or something, then that definitely shouldn't stop you from being an SRE. Like those skills can be developed, and also a lot of it is you can always ask for help if you don't understand something.
Okay, thank you.
Yeah, cool.
Yeah, I think Jamar's still typing his question out, but I wanted to add just in my interactions, because so my day-to-day work is as a software engineer, but like I just find like the SREs are the people that like they just like understand the systems the best. Like when I don't know, I love going to talk to the SREs because they just they're the people that understand how Google works actually like the best. I feel like a lot of what I do as a software engineer day to day is coding like kind of these pieces of some functionality, but then SREs are the people that like understand how those pieces get run at scale. And you guys may not have had to think about this, but like whenever you travel, if you've ever gone to a different country and you try accessing Google and it just works, or you watch a YouTube video and it just works. Like the fact that it just magically works is because the code that I write has to get scaled somehow. It has to be run in servers all over the world, and your request has to go to a nearest server. And I feel like it's the SREs that know a lot about that stuff. And as a software engineer, all of that is actually abstracted away from me. I don't ever have to think about which server is my my code going to run on. So yeah, just adding some more color. Jamar's question came through. Do you believe that the key skills involved in being an SRE are easily applicable to other occupations as well?
Yeah, I definitely think that a lot of what SREs do is being able to, like you mentioned, understand the system as a whole and understand how different pieces work together, and also communicating, especially if there is an outage, being able to explain what you're thinking, to reach out to people, to be proactive and kind of working with others. And yeah, I definitely think both of those skills really apply to other occupations. If you were a doctor, I'm not sure if you would need to know how to write code, but the kind of soft skills are definitely applicable.
Okay, Tyler, do you have another question?
Yep, a lot more, just more subjective level. What would you say you enjoy about your job the most?
I think it's the fact that I get to work on new things every day. That's kind of a thing that, the entire field of software engineering and SRE kind of have in common. But I think that SREs really get an ability to look at a system as a whole and be able to explore that and get to work on new things. Like sometimes I'm working on my own projects, sometimes I'm working with other people's projects, sometimes I'm going through and trying to understand how a system works, how I'm debugging. So that's something that I really enjoy.
Thank you.
That's definitely the thing I'm most envious of Gabby and the SREs of, is like I feel like that understanding you don't get as much as just as a regular software engineer. So it's just such a cool role.
Absolutely.
All right. Well, if there aren't any other questions, it looks like there aren't, and we're right on time. Let's all take a minute to thank Gabby and give her a virtual kind of round of applause. Thank you for coming to talk to us. And with that, we'll end the recording. Thank you, Gabby.
Thank you.